Loops are when you can start to feel the true power of computing. They give you the ability to write a fixed amount of code and a block of code that's going to run over and over and over again faster than your mind can comprehend with very little effort. So let's jump into what a while loop looks like and start to get a feel for the power we're actually harnessing inside of our systems when we're writing programs. And this is going to be how we're able to process very large amounts of data in an algorithmic way. So while loops are a control flow statement like if then else with one special feature, which I'll come back to. They look a lot like an if statement. We have the while keyword and then a Boolean test expression and then a colon and then a repeat block, right? So that while keyword, just like if and else, is special to the language. You can't use this as a variable name. And it's very different from the if statement, even though it looks very similar and in some instances behaves kind of similarly, and with some intuition you can carry over. You should not try, I would encourage you to avoid confusing these two things. An if statement is a conditional, a while is a loop, and there's a big difference between conditionals and loops, as we'll soon see. But the while keyword is followed by some test, and then the repeat block. This can, just like an if else statement, the repeat block can be a block of statements of however many statements you want to have inside of it. So like an if statement, what's going to happen when we reach the while syntax here and we try and evaluate this test is if that test evaluates the true, we're going to go into the repeat block, right? If it's false, we're going to jump over it. Right? So this is a lot like an if then without an else. And there is no else component of a while loop, right? Unlike an if, this is the big special feature that's incredibly cool and insanely powerful. When we reach the end of the repeat block, we jump back up to the top, and at that Boolean expression, we're going to test it again. We go through the repeat block. When we reach the end of it, boom, we jump back up to the top, and we're going to test that again. And we're going to keep doing this. The computer is just going to keep looping and looping and looping until that test becomes false, and at which point we're going to jump past the block and continue on in our program. All right? It's going to be running harder and faster on these loops than our minds can even comprehend, as we'll get to see in just a moment. All right? So this is where we really get to harness some fun computational powers. Anywhere you can write a statement, you can write a while loop. So you can put while loops within test conditions, or you can write while loops within if then else blocks, and vice versa. We can have if then else tests within our while statements or within our while blocks. And so on. So we can use these in places to have a lot of control over how we express the logic and the flow of our programs. So let's diagram this control flow process. So we reach this test again, and that's our diamond here. And if it's true, and I apologize for the labeling here. The labeling's a dark color. I'll fix that in post, right? If this is true, then we go into the repeat block. Just like an if test, when that's true, it goes into the then block. Well, in the test case of a while loop, if it's true, we go into the repeat block. And then what's amazing is after the repeat block, we don't continue on in our program. No. That happens in an if then statement. With a while loop, we go back up to the top of the test, we try it again, and if it's still true, we go back into the repeat block. And so you get the sense that, wow, we can have one block of code run over and over and over and over again until something is changed to cause this test to be false. So this is where our looping comes into play. This is what we mean when we have a loop. And you'll see that there's even a visual loop going on, right? This can happen hundreds of thousands, millions of times over. But at some point, we really need that test to become false, right? Otherwise, we'll have what's called an infinite loop, and our program will never complete. Your computer's processor will just be spinning and spinning and heating up, and your fans you'll start to hear your fans kick in, and we don't want that. So we're going to need to learn some strategies for avoiding an infinite loop. And the key strategy is at some point, that test needs to become false, right? So we need that test to become false ultimately, right? And once that test evaluates the false, we're going to skip over the repeat block and continue on in the program at the next line. Right? So let's try writing one of these and getting a sense for how this works. We're going to have a setup just again in VS Code where we're going to have a sample file that we can use. And I'm going to name this file in my lessons directory. I'm going to set up a new file that is ls11 while loop.py. Right? And that name of the file is in my tab here. And we'll make a doc string that says an example of a while loop statement. I'm gonna make an exclamation point because this one's exciting. Right? And our iterations is a word that tells us how many times over we're going to try what's inside of this block, right? And that's going to be an integer value. And just like before, we're going to ask the user for some number. All right, so we're going to convert the input to an integer. How many times do we want this loop to run? Okay. This word iteration is one that you'll see frequently in computing. And just like when you have a project idea or a paper and you iterate on it and you try and make progress on it, there's some actual implication that we want to be making progress towards some goal when we're looping, right? We don't want to just be looping forever. We want to be iterating toward some end goal. I'm going to set up another variable named I that's also going to be an integer and have an initial value of 0. I is a commonly used variable name in programming for what we're about to see, for counting, it's called a counter variable in a loop. And I is chosen kind of historically because in the early days of computing, you could only have one letter variable names in some languages. And I we tend to think of as an index, as we're going to count up the number of times. Each time our loop iterates, we're going to make forward progress by increasing this I value by 1. So I will be 0 and then 1 and 2 and 3. And each iteration, we're bringing I closer and closer to our goal, which is the total number of iterations, right? So our statement here is going to be while I is less than iterations, right? And this is our first while statement. Once again, we've got a Boolean expression here, and we're going to test is I less than the number of iterations, right? So if we enter how many times and it was 100, then this test is initially going to be while 0 is less than 100, right? The first time this is evaluated. And so we're going to need to do something to ultimately make that false at some point. We'll come back to that in just a moment. Let's go ahead and print in repeat block. And let's print something about our variable I here. So maybe we print I is, and then we concatenate the string translation of the variable I. Right? So I is an integer. In order to concatenate that integer to our string, we're going to use a string constructor, the stir function. That's a special constructor function to construct a string from our integer, and then we can concatenate it. And now we're going to do the part that brings us closer and closer to our goal. Right? We're going to increment I. And notice this is, we're iterating on I. Right? We're making forward progress towards this condition being false in the future, right? So we can imagine this if iterations was 1, right? If we said just loop 1 time, then 0 less than 1 is true. That happens the first time, right? So let me actually try and annotate this because I think this is valuable to see before we go try and run this program, right? So when this evaluates the first time, if we had entered 1 here, right? So 0 less than 1, that's true the first time around. So we're going to go into the repeat block. We'll print these things out. And then this statement is saying, okay, take I's current value, which is 0, add 1 to it, and reassign it back to I. Right? So I's value is now going to be 1. And notice that when we reach the end of this repeat block, what do we need to do? We need to go back up and test this condition and ask, is it true or is it false? Well, in this case, is 1 less than 1? No, that's false. So we're going to jump over the repeat block. All right. Now, just to very quickly demo that this would cause multiple repetitions, if we had entered 2 here instead, right? The same things would have happened up until now. We would have printed in repeat block I is 0, then we change I to be 1, and then just like we did before, we would return back up to this test, right? And we're going to jump back up to the test, and test is 1 less than 2. That's true. So we would go back in, we would print in repeat block I is 1, and then we increment I 1 more time. So that when we go back up, I is now 2, 2 less than 2 is false. So notice that would have caused 2 iterations of the loop until it had completed its job. Right? And that same phenomenon holds whether we have 100 iterations or 1,000 iterations and so on. All right. And so now what we can do is let's have just one statement print after repeat block I is, and then we'll concatenate 1 more time, the stir I. Right? So we can just see what our variable I ends with when this is done. Okay. So I'm going to scroll this down just a little bit, and I'm going to open up my terminal. and I need to run the program Python module lessons.ls11_while_loop, right? And so now when this program runs, it asks us how many times do we want to loop. And let's say I press 1, right? In repeat block, I is 0. After repeat block, I is 1, right? No, that's not too exciting, right? Let's try this one more time. But this time I say 100. Boom, look at that. If I open up my terminal, notice that that program just repeated those lines of code 100 times over. And I ended at 90. Inside of the block, the last time that block was evaluated, i's value was 99. And that makes sense because it started at 0, right? So 0 was the first time this loop evaluated. 99 was the last time this loop evaluated. And then after it was done, i's value was 100, right? And because if we entered 100, we want I to be less than 100. That was still true for 99, but that was not true with 100, right? And what's amazing is we could enter a value such as, 10,000, and faster than you could imagine trying to type this out. And if you had asked if I had asked you, hey, type these two lines over and over again, 10,000 times over, a human would be like, no, why in the world would you ask me to do such a horribly boring and repetitive process? But look at what we're seeing here. The computer was more than happy to take this program, which is doing some really pretty mindless stuff, right? We're typing out one line, incrementing a variable, printing out that variable's value, repeat, repeat, repeat 10,000 times over. And what's amazing is if we hadn't have printed out those lines in the middle, what's actually taking most of the time in this program is not our code. It's actually it's the code that causes these values to show up on your screen. Like that's actually pretty expensive. So if we only showed something, if we only ran this block every, say, 1,000 iterations. So we only printed if I was evenly divisible by 1,000, we could see this effect take place, right? So if I remainder 1,000 is equal to 0, meaning if we can divide 1,000 evenly, if we can divide I into 1,000 evenly, then we're going to print in the repeat block and I is some value, right? Otherwise, all we're going to do is we're going to skip over this then block, right? So this is the then block that corresponds to the if. Otherwise, we're going to increment our variable here, all right? So let me just show you that when we do this, we can use a number like 10,000 and we're going to expect to see, 0, 1,000, 2,000, 3,000, 4,000 printed. But this loop is still running 10,000 times over, right? Because this variable is only incrementing by 1 each time. It just so happens that we're only going to print these two lines every 1,000 lines. So let's try this real quick with an input of 10,000. Boom, look at that, it's already done. And so if we're not constantly printing things to the screen or trying to have certain effects show up, if we just want the computer to run and carry out some process on our behalf as quickly as it can in the background and only intermittently give us some results, we can see that like the computer can operate at billions of operations per second. And we're carrying out some complex operations here, more complex than what the computer's doing. The point is it's running incredibly fast. And if we're not printing everything out, it would run even way faster than we can imagine, right? So we could do, 100,000 times and boom, it's already done, right? That loop, that piece of code, those 4 lines of code, the computer evaluated those lines 100,000 times over. It tested whether I was evenly divisible by 1,000 100,000 times over, right? And it went that fast, right? Let's keep dropping zeros in here and we've got 1,000,000. And you can see that like we just ran this block of code 1,000,000 times over. The computer did a division operation and checked the remainder 1,000,000 times. And then it took only every 1,000 times a special case scenario of, okay, I'm going to do this because it's evenly divisible. So hopefully you're getting a sense of the true raw speed that is in your computer. If you think about something just happened 1,000,000 times inside of it with these 5 lines of code. And that's really, really, really a mind-blowing thing when you think about other applications that are far more interesting than this. And this is what's behind all of the really amazing things in computing that you know and love, okay? So what we've just seen here is a common pattern that we'll see many times over in the programs in the weeks ahead, where you want some loop to iterate some specific number of times, right? And so as we're iterating, as we're making forward progress towards our goal, we will tend to start from 0. And starting from 0 has to do with this idea that our sequences start from 0 as well. So like the string, the first character of a string is at index 0. And we'll see when we have lists of other data types, we have an index 0 is where we start from as well. So you almost always are going to start counting from 0. And then you'll test while I is less than some number of times that you want to iterate, right? And so while that's true, we're going to go do something useful. And then at the end of the block, we're going to increment our counter variable I by 1. And this will have the effect, and I would encourage you to think through this and get comfortable with this, of this loop will have to iterate this many times over until it's completed its job. Right? Now you might be wondering, what happens if we don't ever complete our job, or if we have if we forget to update that counter variable, things like that? We'll come back to that in just a moment. But we don't want to introduce an infinite loop in our code. And there are some specific strategies we have for avoiding that. So just as we looked at with the if-then statement, we can think about this in a control flow statement as well, where notice the key difference is we go into the repeat block, we go back up to test, right? So if that test never evaluates to true, or sorry, if that test never evaluates to false, when we go back up to it and test it again, then we're going to have an infinite loop, and we got to be careful about that, right? If you do find yourself in an infinite loop when you're running your program in the terminal, the thing to remember is Control C will stop your program. And I'll give you a demonstration of this in just a moment, right? Because we can actually change this program in a what feels like a tiny way, but has a very big impact ultimately, right? So what if I notice that with this if statement, we've got 2 nested in the then block of this if prints. What if this conditional update, or what if this variable increment only happened when I was evenly divisible by 1000? Well, if we try and reason through this before we run this code, if we try and imagine, well, I starts out at 0, 0 is less than, call it 1,000,000, that's true. 0 is evenly divisible by 1000, or it doesn't have a remainder when you try and divide it by 1000. That actually is true. 0 divided by anything doesn't have any remainder, right? So we go into the then block, we'll print I is 0, and then we increment I so that I is 1, right? Because that's part of this if then block. We reach the end of that then block, we reach the end of the repeat block, and so we go back up and we test this again. Now we say, is 1 less than 1,000,000? Yes, that's true. So we go in and we say, is 1 evenly divisible by 1000? No, it's not, right? So, we don't do anything in this then block, right? We skip over all of it, including this increment, right? So this is now a part of this condition. This statement incrementing I is only going to happen when I is evenly divisible by 1000. So we jump back up to the top and I is still 1. And notice it's just going to keep repeating and repeating and repeating, because once we get into that place where the only way that this variable was going to update if I was evenly divisible by 1000 is never going to be true again, right? So this will be an infinite loop. And just to show you what happens when we do this, let's try it. So I'm going to run my program. How many times? We'll call it a bunch. And notice here, nothing seems to be happening, but in the background, I can actually hear my computer heating up, which is bad because my AC is broken and I'm already sweating, right? But my computer is running hard. If I showed you my task manager for just a moment, which shows us our programs, notice that with my CPU here, Python is just continuing to use my processor. It's trying to run this code over and over again. It's doing exactly what I told it to do. Right? It's following my rules to the T, and the computer will always follow your rules to the T. The problem is I wrote the rules wrong. I wrote some code here that doesn't make progress towards this. So my computer's looping, it's looping, nothing's happening. But if you press Control C, you'll notice that, I also pressed the up key. So if you press Control C, it stops that program. My fans in my computer have slowed down. My computer's like, oh, I can breathe again, right? Like it was just running as hard as it could. And it's like, I don't think this feels right, but I love running your code for you anyway. So it's just hammering at this code and making no forward progress. It's not actually iterating, even though it's looping many, many times over. So this is an infinite loop. And this gives us a hint at what might cause an infinite loop, right? So we've got to be very careful with indentation. There's a big difference. This was a non-infinite loop, and this was the correct way that we wanted to implement this loop. But with one level of indentation, we have an infinite loop. So we've got to be very careful here, right? So I'm going to save this, and I want to give you just a few strategies for avoiding infinite loops. So the first is you have to remember to update your counter variable. In this example, we're not updating our counter variable at all. I is always 0. This would be an infinite loop if n was greater than 0, right? Nothing changed inside of the repeat block in order for I to become closer to our end goal. When we're iterating, we're trying to make forward progress towards some goal, right? Similarly, with the second example here, notice we're saying, well, I is less than n, so n is some positive number, imagine, but notice we're actually decreasing the value of I. So we're moving away from our goal. We thought we were iterating, and we are changing I, but we're not making progress towards the goal. So not only do we need to change our variable, we need to change it in a way that brings us closer and closer to our end goal, right? And lastly, a good example that solves both of these is what we started with, right? We say I is less than n and assume that n is some positive value here. It actually could be negative, and that would be fine too, as long as I started out less than it. If it started out greater than it, we would skip over the repeat block and it just wouldn't run, right? But here, we've got a less than, so we know that I needs to be growing until it's equal to n or potentially greater than n. And in the loop body, in the repeat block, outside of any other conditional or anything like that, we're sure to be making forward progress towards it. As you can imagine, we could increment by more than 1 to have different patterns. So if we wanted to count up by 2s, we could do things like that. We'll explore more looping patterns as we move forward. So this is an introduction to while loops. They are in conjunction with if, then, else, and function calls, bread and butter power tools for how we can achieve significant amounts of computational work in our programs with smaller amounts of fixed amounts of code. Right? So I hope this was an enjoyable exercise. I would encourage you to play with loops, and we're going to have an interesting practice problem with loops coming up. Great work.